Imagine standing beside a machine taller than a two-story house. In less than 2 minutes, it transforms a handful of tiny plastic pellets into a rugged industrial drum strong enough to carry dangerous chemicals across oceans. Most people see a blue plastic barrel and think it's just another container. But here's what nobody tells you. Its journey begins nearly 3 kilometers beneath the Earth's surface. Think about this. Every year, hundreds of millions of plastic drums transport everything from food ingredients and pharmaceuticals to hazardous industrial chemicals. One small manufacturing defect could leak toxic liquids, contaminate valuable products, or create environmental disasters. That's why every drum begins a remarkable engineering journey driven by science, precision, and incredible automation. Today, you'll travel from oil fields and petrochemical plants to high-speed extrusion lines, massive blow molding machines, robotic inspection systems, and laboratories where every drum must prove its strength before reaching customers around the world. What happens next surprised even experienced manufacturing engineers. And this is where it gets truly extraordinary. Everything starts with crude oil and natural gas extracted from countries, including the United States, Saudi Arabia, Canada, Qatar, and the United Arab Emirates. Inside enormous petrochemical complexes, hydrocarbons are separated into ethylene through steam cracking at temperatures approaching 850 degrees Celsius, 1,562 degrees Fahrenheit. This invisible gas becomes a building block for one of the world's most important plastics, high-density polyethylene, better known as HDPE. The ethylene molecules enter huge polymerization reactors operating under carefully controlled temperatures and pressures. Millions of tiny molecules connect together into long molecular chains, creating HDPE resin with outstanding impact resistance and chemical stability. Engineers monitor density, melt flow index, and molecular weight because even small variations can weaken the finished drum. Next, the molten plastic passes through underwater pelletizers that slice it into perfectly uniform pellets only a few millimeters wide. Each industrial drum will eventually require roughly 7 to 10 kilograms of these tiny pellets. Millions of identical pellets flow through conveyors every hour, creating what looks almost like rivers of white pearls. Before shipping, manufacturers mix ultraviolet stabilizers, antioxidants, processing aids, and color master batches into the resin. Blue remains one of the most common colors because it helps protect light-sensitive chemicals while offering excellent outdoor durability. Every batch receives laboratory testing before thousands of tons leave the factory by rail cars, trucks, and cargo ships. Most people never think about the supply chain hidden behind a single plastic drum. A pellet produced in Texas might travel over 12,000 kilometers before becoming a finished drum in Southeast Asia or Europe. Every shipment arrives with certificates verifying purity, contamination levels, moisture content, and food-grade compliance. The factory cannot begin production until every number matches the specification exactly. Environmental responsibility has become one of the industry's biggest engineering challenges. Modern manufacturers recycle production scrap, recover excess heat, reduce energy consumption, and increasingly incorporate recycled HDPE into non-food industrial drums. Some factories now recycle nearly 100% of their production waste. But the real transformation begins when those tiny pellets disappear inside a machine hotter than most people can imagine. The moment the HDPE pellets disappear into the extrusion blow molding machine, everything changes. Inside the heated extruder barrel, rotating screws turn at 60 to 120 revolutions per minute, while temperatures climb from 180 degrees Celsius to 220 degrees Celsius, 356 degrees Fahrenheit, to 428 degrees Fahrenheit. Within just a few minutes, millions of tiny plastic pellets melt into a thick, glowing stream with consistency of warm honey. You can hear the deep hum of the screw, feel the heat radiating from the machine, and smell the faint scent of hot polymer filling the factory. But here's what nobody tells you. The machine doesn't pour plastic into a mold like molten metal. Instead, it continuously pushes out a giant hollow tube of molten plastic called a resin. This glowing tube hangs vertically for only a few seconds before massive hydraulic molds close around it with forces exceeding 250 tons. Timing is everything, because even a slight delay can ruin the entire drum. Now comes the incredible transformation. High-pressure compressed air, typically between 6 and 10 bar, 87 to 145 psi, rushes into the hot plastic tube in less than a second. The molten plastic instantly expands against every contour of the chilled steel mold, perfectly forming the drum's ribs, handles, and reinforced walls. Watching it happen feels almost like seeing a balloon inflate in slow motion, except this balloon will soon carry hundreds of kilograms of industrial chemicals. While the plastic takes shape, thousands of liters of chilled water circulate through channels hidden inside the mold. These cooling circuits maintain temperatures between 10 degrees Celsius and 20 degrees Celsius, allowing the drum to harden evenly without warping. The cooling cycle usually lasts 45 to 90 seconds, depending on the drum size and wall thickness. What looks simple outside is actually controlled to fractions of a second. As soon as the mold opens, a robotic arm quickly removes the newly formed drum before another production cycle begins. Modern factories repeat this process every 60 to 120 seconds, producing hundreds of drums during a single shift. The robots move with incredible precision because every second saved increases production without sacrificing quality. It's an endless rhythm of heat, air, and automation. The drum still isn't finished. Automated trimming stations remove excess plastic, known as flash, using high-speed rotating cutters and precision blades. Powerful vacuum systems immediately collect every plastic shaving, so it can be ground into reusable material. Almost nothing goes to waste inside a modern plastics factory. Next, computer-controlled drilling machines create perfectly aligned openings for threaded caps and sealing systems. Each opening must remain accurate within plus or minus 0.3 millimeters, ensuring complete leak protection throughout years of use. Sensors instantly verify every dimension before the drum moves forward. One incorrect measurement means automatic rejection. Now, every drum enters one of the factory's most important safety tests. Automated leak testing equipment fills a container with compressed air while sensitive pressure sensors search for microscopic leaks. Some systems detect pressure losses smaller than 0.02 psi, revealing holes invisible to the human eye. The entire inspection takes less than 30 seconds, but it protects products worth thousands of dollars. Finally, the finished drums receive permanent identification through laser marking or hot stamp printing. Every container carries manufacturing dates, batch numbers, recycling symbols, UN certification marks, and traceability codes that follow it throughout its entire working life. Within minutes, a simple pile of plastic pellets has become a highly engineered industrial product trusted around the world. But manufacturing is only half the story. Before these drums can transport hazardous chemicals, food ingredients, or pharmaceutical materials across oceans, they must survive brutal impact tests, crushing forces, leak inspections, and AI-powered quality control systems. What these containers endure next surprises even experienced engineers. Before a single plastic drum leaves the factory, it enters a world where perfection is the only acceptable result. High-speed robotic inspection systems, equipped with AI vision cameras, scan every surface while the drum rotates 360 degrees. These systems detect scratches, dents, flash, wall thickness variations, and tiny molding defects as small as 0.2 millimeters. A flaw invisible to the human eye can still trigger an automatic rejection. Next comes ultrasonic wall thickness inspection. Powerful sensors measure the drum's walls at dozens of locations without cutting it open. Every reading must remain within tight tolerances, typically plus or minus 0.3 millimeters, ensuring the container can safely withstand stacking loads and transportation impacts. Engineers know that uniform thickness is the secret behind a drum that lasts for years. But here's where the real punishment begins. Sample drums undergo drop tests from heights of 1.2 to 1.8 meters, depending on international certification requirements. Some are filled with water, while others carry test liquids that simulate hazardous chemicals. The impact echoes to the laboratory, and every crack, dent, or leak is carefully recorded. Compression testing pushes the drums even further. Massive hydraulic machines apply loads exceeding 4,000 kilograms, simulating months of warehouse stacking and international shipping. Engineers watch every fraction of a millimeter as the drum flexes under pressure. If it permanently deforms beyond specification, production stops until the problem is solved. Leak testing continues under even harsher conditions. Automated equipment pressurizes every drum, before monitoring pressure changes for several seconds using extremely sensitive electronic sensors. Some systems detect leaks smaller than a single pinhole. The rejection rate usually remains below 1%, thanks to constant process monitoring and automated quality control. Most people think robots do everything, but that's not entirely true. Experienced technicians still inspect sealing surfaces, threaded openings, and molded handles by hand because trained human fingers can detect tiny imperfections that machines occasionally miss. Years of experience often outperform even the smartest algorithms. Human craftsmanship still has an important place inside this highly automated factory. Only after passing every inspection does a drum receive internationally recognized certifications, such as UN ISO 9001, and, when required, food contact approvals. Every barcode allows manufacturers to trace the drum back to its exact production batch, machine settings, operator, and raw material supplier. That level of traceability makes modern quality control incredibly powerful. But the story doesn't end inside this factory. Let's zoom out to the global picture. Every year, manufacturers produce well over 150 million industrial plastic drums, supplying industries in more than 180 countries. The global market is worth over $15 billion, driven by chemicals, pharmaceuticals, food processing, agriculture, and petroleum industries. Demand continues to grow as international trade expands. China leads global production, followed by the United States, India, Germany, and Japan. Together, these manufacturing powerhouses produce well over half of the world's industrial plastic containers. Thousands of factories employ hundreds of thousands of skilled workers, while supplying nearly every major industry on Earth. Without them, global supply chains would slow dramatically. Did you know that a single 220-liter plastic drum can safely transport liquids weighing over 250 kilograms? Did you know modern HDPE drums resist thousands of different chemicals without corroding like steel? And here's the biggest surprise. Many industrial drums complete multiple recycling cycles before becoming entirely new containers, dramatically reducing plastic waste worldwide. 50 years ago, plastic drums relied heavily on manual production and simple machinery. Today, artificial intelligence predicts maintenance before machines fail. Robots handle nearly every heavy operation, and digital twins simulate production before a single pellet melts. Over the next decade, factories will likely become even smarter, faster, and more sustainable through recycled materials and renewable energy. We've traveled from deep underground oil reservoirs to giant petrochemical plants, watched tiny plastic pellets become molten polymer, witnessed enormous blow-molding machines shape industrial containers in seconds, and explored laboratories where every drum proves its strength before reaching customers worldwide. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and we'll see you inside the next factory.